All right, so I've got 4 different examples on here for addition, subtraction, and multiplication and division, and how we account for significant figures in each one of these mathematical transformations. So the first one I've got is 4.18 plus 0.0341. All right? So how do I know what's significant and what's not? Okay? Especially when I try to add something that I know is significant to something that I know is insignificant. This term right here, that term, I have no idea what it is. It could be a 9, it can be a 0. I don't know. It's not measured, it's not reported. This value has uncertainty that's built into it that's here with the 8. So as a result, if I look at 0.431, I can add some things together. I can make this 4, sure. That's a 4, or this a 12, so that'll be 5, okay? And that's a 2, and what do I do with the 1? That's a good question. The answer is, you can't do anything with the 1. Because once I include that 1, I have to report that I'm confident that I know what that term is. And then I have a good idea of what the uncertainty associated with that number is going to be. I have no idea what the uncertainty of that term is going to be, especially when I compare it with something that is unmeasured. So as a result, to be safe, I drop the 1 off. It goes away. Goodbye. All right? So what I'm left with is 4.52, and I know that this is going to be 3 significant figures here at the end. Okay? If I look at this one over here, all right, I start doing some subtraction associated with this, and I run into the same problem. Okay? Now, it depends on whether these values are measured. So if I look at this and I know that this is a measured value, okay, I know that there is some significance here, especially with that 8. Now, I know that 8's close to 1, and there's a pretty good chance that whatever's there is going to get me to that point. So I'm okay with the idea of rounding this. So I remove that 8 and 3 because I know that they can't be significant, but because I measured that 8, I'm okay rounding that to 2. Okay? So now, I go ahead and subtract, okay? Do long subtraction because you haven't seen this in a very long time. That's 9. Okay, 0, 13, that's 6, and that's 8.69. Now, wait a minute, Dr. Ruane. I had 4 significant figures here to start with, and I had 5 significant figures here to start with. Are you telling me that I'm going to end up with 3 significant figures? Whoa, what's going on? If you thought that, you're right. But that's a function of significant figures, is that when you add and subtract them, there is a possibility of losing a significant value or more, okay? Because the magnitude shrinks, and when that happens, the number shrinks, your significant figures are going to shrink there as well. Now let's look at these numbers. How many significant figures does this one have? If you said 5, that's correct. Okay, so this one's got 5 significant figures. And what about with this one? This one has, are these significant? Are these zeros significant? They come before non-zero numbers, okay, which means that they are going to be magnitude values, so that they're placeholder zeros. So as a result, the only significant figures I've got are right here at the 151. So this one has 3 significant figures. Right, so if I have 3 significant figures, 5 significant figures, the value that I'm going to get out at the end is always going to be the lower number of significant figures. So whatever these equal to, I have to be confident that at the end I've got to have 3 significant figures. Anything more than that, and that's goofy. Even if the number changes dramatically as far as number size goes, and I calculate this and look at my calculator and it's giving me 12 digits, the calculator doesn't know significance from a hole in the ground, okay? You guys have to figure that out. So if I do this and I calculate this number, what I'm going to get is a significant value. All right? So I go ahead and type that into a calculator. And what I get is this number in my calculator. 1.269953. Right? So which values are significant? Which three numbers are you going to pick to be significant? And it's going to be the numbers that are the biggest, that are the closest to the end there. Okay? The end over here. Notice that the last number there is a 9, so it's okay to round that number. It's okay to round when you're done at the end of all calculations. Do not round in the middle of calculations, because when you do that, you're going to end up magnifying any error that you have associated with it. Okay? It's okay to round at the end, but not in the middle. Okay, so the real value for this is going to be 1.27. Okay? Now what about this bottom one? I've got two significant figures here. And I've got 4, we got more than that. I've got 4, and what about these other zeros? Are they significant? They trail a non-zero number after a decimal. So, yeah. So 1, 2, 3, 4, 5, 6. All of those numbers are significant. So, let's see. That's 6 sig figs. How many sig figs should I have at the end? And this is one of those terrible situations where you look at it and say, well, all those zeros, it would be great to keep all those significant values, but the truth of the matter is I can't keep them. Not at all. So when I plug this into a calculator, I get 18.5, which is 3 significant figures. And it's wrong. Why is that wrong? It's wrong because I've got too many significant figures in my final answer. Remember the burette from the previous example? If I use 0 there at the top, that's one significant figure. All of my values are going to boil down to one significant figure. That's not great as far as measurement goes. So this, with two significant figures, it handicaps my answer. The smaller the number of significant figures, the greater the handicapping of your final answer. So this is not 18.5. I can round this. My overall answer is going to be 19, even though I've done some fantastic and precise work in measuring 4.00000. Okay? Same type of thing. Suppose I take I would do this and I multiply this 74 times 40. All right? What's going to be my overall number of significant figures? All right? When I do my calculation, my calculator just says, Shaw, it's easy. Hello, 2960. That's my number. That's my answer. Okay? But what about significance? How many sig figs do I have here? 2. That hasn't changed. That's right. How many sig figs do I have there at the 40? Not 2. 1. Because the way I've written this, I'm not sure if that 0 is a real number or not. Okay? Is it significant or not? I don't know. So I can only with confidence say that that's one significant figure. So my answer has to have one significant figure. So this number that I've calculated out, I have to round it down to 3,000. But even then, that's not a correct answer. Why not, Dr. Uwe? Well, look at those zeros. Are those zeros telling me that they're significant values or not? I can't tell from here. A better answer here would be 3 times 10 to the 1, 2, 3. So 3 times 10 to the 3 would be my best answer to that particular query. Okay? You need to practice some of these. Okay? So do the assigned problems with this practices. We'll do practices like this in the class. Bring them to your SI. Okay? Good.